Now in last session we have seen about equation of stationary waves. So the equation is y is equal to a sin of omega t. A is the resultant amplitude. Then a is equal to twice a cos of 2 pi x upon lambda. Now x is the displacement, lambda is the wavelength, a is the resultant amplitude. Now today's one is condition for nodes. Now nodes is the point at which the displacement is minimum, for which the amplitude becomes minimum. So what is the condition for nodes? Let us discuss. Now you know the equation of the amplitude. A is equal to twice a cos of 2 pi x upon lambda. It is the equation of resultant amplitude. Now condition for nodes. It is the point at which the amplitude is minimum. Therefore, a is equal to 0 means twice a cos of 2 pi x upon lambda is also 0. Twice a cos of 2 pi x upon lambda is also equal to 0 because at node point amplitude is minimum, which is equal to 0. Now cos of 2 pi x upon lambda is equal to 0. Now when cos is equal to 0, when the 2 pi x upon lambda is equal to pi by 2, 3 pi by 2, 5 pi by 2. Therefore, when x is equal to, here cos of 2 pi x upon lambda is equal to 0. Then when cos of 2 pi x upon lambda is equal to 0, that time the value of cos is equal to 0. Therefore, here we want 2 pi x upon lambda is equal to pi by 2, 3 pi by 2, 5 pi by 2, etc. When the value of 2 pi x upon lambda is equal to pi by 2, 3 pi by 2, 5 pi by 2, then cos value is equal to 0. Now we want to calculate the value of x. So first we consider first value 2 pi x upon lambda is equal to pi by 2, which is equal to pi by 2. It is calculating the value of x. So what is the value of x? From this equation, here pi get cancelled, pi get cancelled, then x is equal to lambda by 4. Here x is equal to lambda by 4. Now again we consider second value 2 pi x upon lambda is equal to 3 pi by 2. Then pi get cancelled, x is equal to 3 lambda by 4. So we get the value of x here. First x is equal to lambda by 4, then 3 lambda by 4, then 5 lambda by 4, like this. Therefore, the general formula of x is equal to twice p minus 1 lambda by 4, where p is equal to 1, 2, 3, 4, etc. Where p is equal to 1, 2, 3, 4, etc. या ठिकाणी आपण बघतोय कंडिशन फॉर नोड्स. एम्प्लिट्यूडचा फॉर्म्युला तुम्हाला माहिती आहे a is equal to twice the cos of 2 pi x upon lambda. Now at point nodes म्हणजे नोड्स या ठिकाणी पॉईंटची व्हॅल्यू जी आहे म्हणजे डिस्प्लेसमेंट जी आहे ती मिनिमम असते, म्हणजेच अँप्लिट्यूड सुद्धा मिनिमम असतं. मग ही अँप्लिट्यूड मिनिमम म्हणजे किती असणार आहे? 0 असणार आहे. अँप्लिट्यूडचा फॉर्म्युला हा आहे. पण नोड पॉईंटला अँप्लिट्यूड 0 आहे, म्हणजेच टॉइस इन कॉस ऑफ 2 पाय x अपॉन लॅम्बडा याची पण व्हॅल्यू 0 असणार आहे. Therefore, twice in cos of 2 pi x upon lambda is equal to 0. Cos of 2 pi x upon lambda is equal to 0 because here 0 upon 2 twice a is equal to 0. Now when cos value is equal to 0 म्हणजे cos ची व्हॅल्यू 0 केव्हा असेल? ज्या वेळेस 2 pi x upon lambda याची व्हॅल्यू pi by 2, 3 pi by 2, 5 pi by 2 एवढी असेल त्यावेळेस cos ची व्हॅल्यू 0 असेल. So 2 pi x upon lambda which is equal to pi by 2, 3 pi by 2, 5 pi by 2 etc. मग आता इथे आपल्याला x ची व्हॅल्यू कॅल्क्युलेट करायची. Therefore here we consider first value means pi by 2. So 2 pi x upon lambda is equal to pi by 2. Pi get cancel. We get the value of x is equal to lambda by 4. Again we consider second value 3 pi by 2. We get the value 2 pi x upon lambda is equal to 3 pi by 2. Here pi get cancel again. X is equal to 3 lambda by 4. Therefore x is equal to lambda by 4, 3 lambda by 4, 5 lambda by 4 etc. So what is the general formula for the x is equal to twice p minus 1 into lambda by 4 where p is equal to 1, 2, 3, 4. म्हणजे या फॉर्म्युल्याने आपण x ची व्हॅल्यू काढू शकतो ज्यावेळेस आपण p ची व्हॅल्यू 1, 2, 3, 4 एसेट्रा याच्यामध्ये सबस्टिट्यूट केल्यावर. तर यामध्ये ही कंडिशन आहे. त्यानंतर आपण बघितले काल स्टेशनरी वेव्ह, त्यामध्ये नोड्स आणि अँटी पॉईंट्स बघितले. सो द डिस्टन्स बिटवीन टू सक्सेसफुल नोड, व्हॉट इज द डिस्टन्स बिटवीन two successive nodes? Let us calculate. First we consider 3 lambda by 4 and then lambda by 4 minus lambda by 4 is equal to 2 lambda by 4 which becomes lambda by 2, which becomes lambda by 2. Now again we consider next example 5 lambda by 4 minus 3 lambda by 4 which also becomes lambda by 2. So the distance between two successive nodes is lambda by 2. It is the lambda by 2. So it is the condition for nodes. Now let's find this condition for antinodes. Condition for antinodes. Again, antinode is the point at which the displacement is maximum, means amplitude is also maximum. Then formula of amplitude A is equal to twice a cos of 2 pi x upon lambda. Now at antinode amplitude is maximum. Therefore amplitude should be plus minus twice a. Plus minus here twice a. Now the amplitude becomes here it should be plus minus twice a. A is the amplitude which is maximum at antinode. Therefore twice a cos of 2 pi x upon lambda is equal to plus minus twice a. Then cos of 2 pi x upon lambda is equal to plus minus twice a upon twice a, which becomes plus minus 1. Therefore cos of here we get the value of 2 pi x upon lambda is equal to plus minus 1, which is equal to plus minus 1. Now when the cost value is plus minus 1, when 2 pi x upon lambda is equal to 0, pi, 2 pi, 3 pi, etc. Therefore 2 pi x should be 0, pi, 2 pi, 3 pi, etc. So let us calculate again the value of x. So first we consider 0. Then 2 pi x upon lambda is equal to 0. Therefore x is equal to 0. We get in first example x value is equal to 0. Then next example 2 pi x upon lambda is equal to pi. Then pi get cancelled. We get the value of x is equal to lambda by 2. Now next example 2 pi x upon lambda is equal to, here we consider 2 pi. 2 pi get cancelled, x is equal to lambda. Therefore we get the value of x here. X is equal to 0, lambda by 2, lambda, 3 lambda by 2, etc. So what is the general formula of x is equal to lambda p by 2, where p is 0, 1, 2, 3, etc. यामध्ये आपण बघतोय condition for antinodes. You know the formula of amplitude. A is equal to twice the cos of 2 pi x upon lambda. Antinode is the point where the displacement is maximum, for which the amplitude should be maximum. Amplitude A is equal to maximum means it should be plus minus twice A. So twice A cos of 2 pi x upon lambda should be plus minus twice A. Therefore here we get cos of 2 pi x upon lambda is equal to plus minus twice A upon twice A, which becomes plus minus 1. Then when the value of cos is equal to plus minus 1, when the value of 2 pi x upon lambda is equal to 0, pi, 2 pi, 3 pi, then we here calculate the value of x. In first example, the value of x becomes x is equal to 0. Then in second example 2 pi x upon lambda is equal to pi, pi gets cancelled, x is equal to lambda by 2. In third example 2 pi x upon lambda is equal to twice pi. Then 2 pi get cancelled, x is equal to lambda. Therefore we get the value of x which is equal to 0, lambda by 2, lambda, 3 lambda by 2, etc. Now the general formula for x is equal to lambda p upon 2, where p is equal to 0, 1, 2, 3. Means we can calculate the value of x by using this formula by substituting the value of p. Therefore x is equal to lambda p upon 2. So it is the condition for antinodes. Now the distance between two successive antinodes. So what is the distance between two successive antinodes? Let us calculate. First we consider the example first. Lambda by 2 minus 0, which becomes lambda by 2. Next lambda minus lambda by 2. Lambda minus lambda by 2, which is equal to twice lambda minus lambda divided by 2, which becomes lambda by 2. In third example, 3 lambda by 2 minus lambda, 3 lambda by 2 minus lambda is equal to again lambda by 2. So we get the same value, lambda by 2 2, here lambda by 2. Therefore, distance between two successive antinodes is lambda by 2, which is lambda by 2. Again, in first condition, we get the distance between two successive nodes, which is also lambda by 2. So here we discuss the condition for nodes and antinodes. So what is the conclusion? The distance between two successive nodes is equal to lambda by 2. Also, the distance between two successive antinodes is equal to lambda by 2. Now, next point is properties of stationary waves. So, what are the properties of stationary waves? You know the stationary wave. You also know the equation of stationary wave, the condition for nodes and antinodes, and the distance between two successive nodes or antinodes is equal to the lambda by 2. So it is the conclusion. Now next point is properties of stationary waves. Now properties of stationary waves. What is the first property? Stationary waves are produced due to superposition of two waves. So which is the definition? Stationary waves are produced due to superposition of two waves either transverse or longitudinal, either transverse or longitudinal. To a medium, along same path, in opposite direction, So what is the definition of stationary wave? Stationary waves are produced due to superposition of two waves, either transverse or longitudinal waves, through a medium along same path but in opposite direction. So it is the definition of stationary wave, and it is the first property of stationary wave. Now either transverse or longitudinal wave. Transverse wave means where the particles vibrate in a direction perpendicular to the direction of propagation of wave, and longitudinal wave means the particle vibrates in a direction parallel to the direction of propagation of the wave. Now first we consider transverse waves. Then in last session we have seen the example of string. A string is fixed between two points. It is the string, and when we pull the string at a middle point and then release, then what happens? The wave is produced like this. Here wave is produced. Now again, after inflection, this wave is produced. Now it is the transverse wave. This wave is transverse wave. So when two transverse waves superpose or interfere to each other, then the resultant wave becomes a transverse stationary wave. So it is the transverse stationary wave. Transverse stationary wave. It is the second point. It is the first point. It is the definition. And second point is transverse stationary wave. Transverse stationary wave means when two transverse waves are produced due to superposition. Means when two transverse waves superpose to each other or interfere to each other, then the resultant wave, you can see in this diagram, the two waves are superposed to each other through a medium along the same path but in opposite direction. Therefore, the resultant wave is known as the transverse stationary wave. Now, in the transverse stationary wave, there are some points where the particles do not move, means there is no motion. So, this point is known as the node point. This point. There is no motion of the particle. So, this point is known as the node point. And you can observe this diagram. There are some points where the particles oscillate with maximum amplitude. So, this point, here the particle oscillates with maximum amplitude. So, this point is antinode. And the particles oscillates from node to antinode. Means the amplitude is from 0 to A. From 0 to A. Here from 0 to A. So it is the property. First property is stationary waves are produced due to superposition of two waves, either transverse or longitudinal, through a medium along same path in opposite direction. Now what is meant by transverse stationary wave? When two transverse waves superpose to each other or interfere to each other through a medium along the same path but in opposite direction. You can see the waves are in opposite direction and along the same path. So the resultant wave is known as the transverse stationary wave. There are some points where the particles do not move. They are raised position. So the point is known as the node. The point where the amplitude is maximum, this point is known as the antinode, and it varies from 0 to A. It varies from, means amplitude varies from 0 to A. Now the third property is here we consider third property longitudinal stationary wave. Longitudinal stationary wave. Longitudinal stationary wave means when two longitudinal waves interfere to each other or superpose to each other along the same path through a medium in opposite direction, then the resultant wave is known as the longitudinal stationary wave. Let us consider one example. Here we consider a tube or pipe. The wave is longitudinal wave. So the point is here. This point is antinode. This point is node. This point is antinode. Now observe in this diagram the two waves superposed to each other along the same path through a medium but in opposite direction. Therefore, the resultant wave is known as the longitudinal stationary wave. Now, again in this wave, longitudinal stationary wave, there are some points where the amplitude is minimum, means the point where the amplitude is minimum and is known as the node point. The point where the amplitude is maximum, this point is known as the antinode. Again, the node and antinode varies from 0 to A. Again, here 0 to A. It varies from 0 to A. And the wave propagates along the loop. Here we consider the points. This point is antinode. This point is node. Again, this point is antinode. This point is node. So it is the third property in longitudinal stationary wave. Longitudinal stationary wave means the two longitudinal waves superposed to each other or interfere to each other through a medium along the same path but in opposite direction. The resultant wave is known as the longitudinal stationary wave. Longitudinal stationary wave, for example, we can say sound wave. Now, the point where the amplitude is minimum is known as the node. Here amplitude is minimum. And the point where the amplitude is maximum, the point is known as the antinode. And this amplitude varies from 0 to A. From node to antinode, this amplitude varies from 0 to A. Now, what is the next property in stationary wave? The next property, 4 number, the distance between two successive nodes or two successive antinodes is equal to lambda by 2. The distance between two consecutive nodes is lambda by 2. And the distance between two consecutive antinodes is lambda by 2. Next property is 5 number. The distance between two adjacent node and antinode is lambda by 4. Is lambda by 4. Then next property is 6 number. Let us discuss fourth property. The distance between two consecutive nodes is lambda by 2 and the distance between two consecutive antinodes is lambda by 2. म्हणजे आत्ताच आपण कंडिशन फॉर नोड्स अँड अँटिनोड्स डिस्कस केलेले त्यामध्ये आपण बघितले की डिस्टन्स बिटवीन टू consecutive nodes किंवा डिस्टन्स बिटवीन टू consecutive antinodes हे लॅम्बडा बाय 2 मिळालेलं आहे. सो इट इज द फोर्थ प्रॉपर्टी. Then fifth number, the distance between two adjacent nodes means the distance between adjacent node and antinode is lambda by 2. You can see in this diagram, node point is here and antinode point is here. It is the antinode. So the distance between adjacent node and antinode, it is equal to the lambda by 4 and the distance between two antinodes or nodes which is lambda by 2. It is lambda by 2 or the distance between two nodes which is lambda by 2. Which is lambda by 2. So it is the fourth property. The distance between two consecutive nodes. This point is node. This point is node. It is the lambda by 2. And the distance between two consecutive antinodes, it is the lambda by 2. The distance between the adjacent node and antinode, which is equal to the lambda by 4. So it is the fifth property. Now let us discuss the next property, 6 number. There is no propagation of energy, so velocity is 0. Velocity is 0. Means wave is localized. Then 7 number, the particles, when the particles in the adjacent node, that time they are in phase. When the particles into adjacent nodes, when the particles into adjacent node point, that time they are in phase. When the particles in adjacent nodes or in one loop or in loop, then they are in phase. Then they are in phase. Next property is amplitude varies periodically. Amplitude varies periodically. So it is the properties of stationary wave. You know the formula of amplitude. A is equal to twice A cos of 2 pi x upon lambda. At node point, amplitude is minimum. At antinode point, amplitude is maximum. So it varies periodically. So these are the properties of stationary waves. First property is stationary wave produced due to the superposition of two waves through a medium along the same path in opposite direction is known as the stationary wave. Second property is transverse stationary wave. When two transverse waves superposed to each other interfere to each other along the same path in opposite direction, then the wave is known as the transverse stationary wave. The point where the particles do not move is known as the node. The point where the particles move, the point is known as the antinode. Amplitude varies from 0 to A. Then longitudinal stationary wave, where two longitudinal waves superpose to each other along the same path in opposite direction, then the resultant wave is known as the longitudinal stationary wave. There is also node point where the amplitude is minimum and node where the amplitude is maximum, which varies from 0 to A. Then next point is the distance between two consecutive node or two consecutive antinodes, which is equal to the lambda by 2. Then distance between two consecutive, the distance between the adjacent node and antinode, which is equal to lambda by 4. And the velocity is 0 because there is no transfer of energy. So wave is localized. Now second number, when the particle in adjacent node or in loop, then they are in phase. Eighth number, amplitude varies periodically. A is equal to twice the cos of pi x upon lambda. At node point, amplitude is minimum. At antinode point, amplitude is maximum. So these are the properties of stationary wave. Now next point is comparison between progressive wave and stationary wave. Comparison between stationary wave and progressive wave. So first point, see in this diagram it is the stationary wave and the progressive wave like this. Stationary wave and here progressive wave. It is the progressive wave. Now what is the difference between the stationary wave and progressive wave? You know the definition of progressive wave. Progressive wave means the waves which travels continuously in one direction, in the same direction, in one direction, and the oscillating disturbance traveling through a medium, with a definite velocity. Also, here it is the progressive wave. So it is the progressive wave and it is the stationary wave. So what is the difference between progressive wave and stationary wave? You can see in this progressive wave. Progressive wave means the wave which travels continuously in the same direction is known as the progressive wave. Means the oscillating disturbance traveling through a medium with a definite velocity. This wave is known as the wave. But in transverse stationary wave, this is stationary wave. What happens? The disturbance traveling. There is no disturbance traveling through a medium. So velocity is equal to 0. So first comparison is here the velocity is infinite velocity. Second is in stationary wave velocity is equal to 0. Now second comparison is in progressive wave. The particles do not vibrate, do not cross the mean position simultaneously. If you consider this particle, they do not cross mean position simultaneously. They do not cross mean position simultaneously. Suppose here we consider this position, then all particles come one by one. Means they do not cross the mean position simultaneously. But in stationary wave, what happens? Here we consider ST. And when the distance becomes minimum, that time all the particles cross this mean position simultaneously. Now in progressive wave, the amplitude is same of all the particles. Suppose here we consider this position, the particles travel through this medium, and that time amplitude is same. All the particles having the same amplitude in progressive wave. But in stationary wave, the amplitude is different of this particle. Amplitude is different of this particle. Now in stationary wave, there are some point where the particles do not move. There is no motion. So this point is known as the node point. This point is known as the node point. In progressive wave, all the particles travels, they are moving. Then in progressive wave, energy is transferred. Energy is transferred from one region to another region. In stationary wave, energy is not transferred. In progressive wave, there is no phase is same. The particles are not in same. But in stationary wave, what happens? Suppose we consider the particles are in adjacent nodes. Then they are in loop. They are in phase. So it is the comparison between progressive wave and stationary wave. We discussed today the properties of stationary wave and the comparison between progressive wave and stationary wave. Now next point we will see